Well, welcome to Chapter 12. Chapter 12, we're going to get into this thing called GUI applications. GUI is short for Graphical User Interface. So we're going to be able to create forms and buttons and radio buttons and labels and all kinds of crazy things. So first thing we talk about is this thing called Java. It's called the Java Foundation classes. And there's basically a bunch of graphical user interface parts and pieces in there as well. There's also another one called the AWT, which is the Abstract Windowing Toolkit, or another one called the Swing classes, and we have to import those into our application in order to use them. So, um, if you look on page 756, here is an example of some of the different forms and things we're going to create. And if we look down here in the table, it talks about we have labels like the name and the list. Well, list is different. Um, we have text fields, which is that box right there. A combo box, which is a drop down. We have a check box, allows us to put check marks in there. We can, if we have multiple check marks, we can put one or more or none. We have a list where we can just make a selection of one of those, or we can make it an option we can select more than one. We have radio buttons, which means we can only select one. If I select one, I select another one, it deselects the previous one. We also have ones called a slider. Down here at the bottom, we have a close button. Okay, so is that all there is? No, that's just probably the basics that we're going to get started with. But there's literally a whole bunch more that allow us to do these things. So we have the JFC, the AWT, and the swing. JFC consists of several sets of classes that basically it says goes beyond the scope of this book. So we're not going to get into a lot of the JFCs. We're just going to kind of touch on some of them, but we're going to mainly focus on the AWT and the swing classes. So those ones are really kind of get us a start and let us cut our teeth on creating these forms utilizing Java. So the very first thing we have to do, and here on 757 it talks about, and you can kind of read this at your leisure, it talks about some of the limitations you have with the AWT and some of the different roadblocks and things that come up. And so and the JFCs, there was problems there as well. So what they did is starting with Java 2, I believe we're in Java 7 or even 8 right now, so we're way beyond that. But they were able to get past all of those different issues and errors, and so now we're pretty good. We have a pretty good GUI interface that we can create with the Java application. So with when using forms and this GUI interface, there's things called event-driven programming, meaning the user has to do something to kick this code off. For example, you click a click event. We have a hover event. We have a mouse down event and a mouse up event. So let's say, for example, you wanted to do something when the user pressed a mouse button. You probably don't want to do the mouse down event because when they hold that button down, that particular event is kind of like a machine gun. It's basically firing. Where with a mouse up event, when you lift up, you're probably going to do that once. So we'd probably rarely use the mouse down event. We'd use the mouse up event. So just things like that. Those are events. So the user is going to do something to kick this code off. So the first thing we have to do is we have to import this Java x.swing class into there. That gives us the coding and classes and instance variables and all the things that come with that when we utilize the graphical user interface as part of Java. So here in the section 12.2 it talks about creating a window. So example is the JOption pane dialog boxes that you learned in Chapter 2 allow you to easily display messages and gather input. If an application is to provide a full graphical user interface, however, much more is needed. Often an application need one or more windows with various components that allow the user to enter and or select and interact with the application. So we come over here and we see this thing called show window. So if we take a look at the code, here is the show window class. So you see that we have the show window, hit public static void main. I've created two constants. One is called the window width, one is called the window height. Very important when we're dealing with GUI. We have to tell how big is this little window going to be, and so that's probably the very first thing we need to deal with. This is just creating the two constants to deal with those. So we got 350 and 250. So notice up here I've got my import Java X.swing, and I have the JFrame class. So I'm utilizing this thing called the JFrame class, and I'm going to create a window object from the JFrame. So now I have this window object, and again, right now I just have the four. Remember talking about the house? I have my four walls kind of created, but nothing's put inside the house until I do the equal new. So the new basically puts the guts inside of there. So I have new JFrame, and notice that there's nothing inside the parentheses, so there's a no arg constructor inside of the JFrame. So I get through with that line, I have a JFrame. What do I have inside there? Well, I don't know, but I know I have all of the instance variables, I have all of the methods that go along with the JFrame. So I take my window and I have .set title. So apparently there's a title instance variable, and we have the set title, and I put a simple window. We'll see what that looks like here in a minute. And then I have window.setSize, and there is my window width and my window height. So it looks as though when the numbers we put in there, the first number is always the width, the second number is always the height. And then I have window.defaultClose operation, which is very important. We have to say, what is this going to do when we click on the X in the upper right hand corner? And this one says it's going to go to the JFrame, exit on close, which means it's going to close and kill that operation in memory. And then we say set visible true. Now, when we do this set default close operation, that it doesn't actually close the operation. It just says, hey, if they click in the upper right hand corner on that X, it will basically take this thing out of memory at that time. Then we go ahead and set. So up to this point, everything's ready to go. Then I have window.setVisible equals true. That's when it displays it onto the screen. So, and that's just it. It's just a window. So if we take a look at this guy and I run it, boom, there it is right there. It says a simple window. So the title, when we set title, that obviously is what's going to display in the title bar of the window. I have my standard minimize, maximize, restore, and close buttons. Okay. And again, when I click on the X, boom, the exit on close just happened, and it took that out of memory. It's no longer in memory, it's no longer running. So pretty simplistic. So again, we always have to make sure we create a window first, and this is probably a nice little piece of code that we can copy and paste in any of our frames that we're going to make, or any of our GUI frames we're going to make. So getting back to the book. So if we take a look at the code again, I kind of stepped through all this, so don't need to read all that. So now we have using inheritance to extend the JFrame class. This is the program in code 12.1, so the show window that we just looked at performs a very simple operation. It creates an instance of the JFrame class and displays it. Most of the time your GUI application will be much more involved in this. As you progress through this chapter, you will add numerous components and capabilities to the window you just created. Instead of simply creating an instance of J class, we can also create a new class that extends from the J class. Okay, we'll see that here in just a sec. So we take a look at simple window. So here is simple window. We take a look at this. Here I've created a class, okay, called simple window, and it extends the JFrame. If we look at show window, it just basically is a class called show window. And I create a JFrame window JFrame. So if I come over here, this guy is actually a component of a JFrame. So inside of there I have public simple window. So what does that do? What is public simple window? Notice it's the same name as a class. Notice it doesn't have a return statement. It's got nothing in the parentheses. This is our no arg constructor. So just instantiating this will cause this to execute. and that's where we get our final window width and height. We set the title, we set the size, we set the close operation, and we set visible equals true. So now the other one was inside of a public static void main. This one is a class all by itself. So what do we need? We have to instantiate it. So let me go back to the book and see what we have to. So simple demo window. So we look at the simple window demo, and there all I'm doing is simple window my window equals new. So we instantiate it, and it executes, and basically the constructor does everything that we just saw in the show window. So I run it, same thing, it creates that window inside the constructor. We're good to go. So not too bad. So a couple different ways. So again, the simple window.java is a JFrame class because it's extended from the JFrame class. So it has everything the JFrame has in it. We can also do this. Now, this is kind of something that's really slick. Let's look at the embedded main. Here it is. So we'll look at it, and it extends to JFrame. So it is a JFrame class. We've got our finals, our two constants. We then have embedded main. That's our constructor. It does all that. Then look at, we now have a public static void main built right into the class. Guess what? I don't need another class to instantiate this. I can do it from the inside of its own class. Okay, that's totally legal to do. So I can just execute this class by itself, and it basically instantiates itself. There it is, simple window. So I can actually put this public static void main as a method, because remember, public static void main is just a method. I can include that method inside the current class. Okay. So now let's add some stuff to this window. We're going to add a label, we're going to add a text field, we're going to add a button. Okay. So what we want to do is we've got this miles, we want to convert miles to kilometers, and I think vice versa. So how the heck do we do that? Well, we're going to create a window title, we're going to create a label that says enter the distance, we're going to create a text field, and we're going to create a button. What we need though is a window. We just can't put those components inside of a window. We have to create a panel first. So a panel is made to hold buttons and labels and radio buttons and all that sort of thing, and then we have to take the panel and put that into a window. So let's take a look at Kilo Converter. So here's Kilo Converter. So again, it's a class Kilo Converter. It extends JFrame. So the Kilo Converter is a JFrame class because it's extended from it. I create a JPanel, which is a panel. So I now have a panel object, which is a JPanel. I have a label, JLabel. I'm calling it message label. Notice these are all private, so these are basically instance variables. I have a text field called Kilo Text Field. I have private JButton called Calc Button, and there's my two constants for the window size. So here I have Kilo Converter. Again, nothing's being returned. It's the same name as my class. Obviously, it's a constructor, no argument constructor. I set my title. I set my width and size of my window. I go ahead and say what happens when you close this. Then I have two extra things here. One is called build panel. So down below there is a build panel method that we are calling. After that we have add panel. Is there an add down here? No. So what add is part of the JFrame class. It says when you say add, it knows to automatically execute the add method inside of the JFrame. And we are going to pass in the panel that we just built. So here's what we do. I create a message. So what is message label? It's a J label. I create that and instantiate it as a new J label called enter a distance in kilometers. Kilo to text field. Again, upstairs was a J text field. I instantiate that as a new JText field, and I'm basically passing in the number 10. Calc button is a J button. I instantiate that as a new J button called calculate. Now what this guy is, this is a label. The button will be created. The button has all kinds of instance variables and methods and things going on there, but one of the things is a label for the button itself, and we can actually instantiate that with the constructor. And then I say panel equals new JPanel, so now I have a panel object, and then I say panel.add, so it looks like the JPanel class has a .add method. We add a message label, we add the kilo text box or text field, and then we add the calc button. So those three things are added to the panel. And then once that panel is built, we add the panel to the JFrame, and then I go ahead and say set visible equals true, which is a method inside of JFrame, and goes ahead and displays the panel. It stays the window with the panel inside of already. Okay, and then down here I've got my public static void main as part of this, and it goes ahead and that will execute, because whenever I click run, it looks for a public static void main. When it finds it, it automatically runs the code inside of that method. So I run this guy, and bam, there it is. Whoop. Let me restart it. There we go. So it says enter the distance kilometers. I can type 100 and click calculate, and nothing happens. Why? We don't have any code for the button yet. Okay, so what we've done so far is we've just created a GUI application. There's no code behind it, so it's doing absolutely nothing. So the next question is, how do we get code added to that button? Well, yeah, let me get to that page. This is, although you can type anything in the text field, basically nothing's going to happen. So we need to put some code in here that has to do things. So now we have to handle the events. And the way we do that is we have to have this code running on our server that is listening. It says I'm waiting to hear if somebody wants me to do something, and then it will take action. Okay, and this is called an action listener. So an event is an action that takes place within a program, such as clicking of a button. When the event takes place, the component that is responsible for the event creates an event object in memory. The event object contains information about the event. Okay, but what happens to the event once it's generated by a source component? It's a possible source component connected to one of those event listeners. An event listener is an object that responds to the events. Okay, so if we come down here to look at the example, here I've got the fields that appear, the fields and methods that appear in the outer class, and then I've got class inner, and the fields and methods in the inner class appear here. So when an inner class is private, as shown in the figure above, it is accessible only by the code within the class it contains, which we already know that. For example, the inner class shown in the figure would be accessible only to the methods that belong to the outer class. Okay. But I want you to kind of grasp what was just explained there. Here I have a class, and I've got a class inside of a class. Ooh, that's kind of wild, because before we've only dealt with just one class. Now I'm going to have a class inside of a class. Event listeners must implement an interface. Okay, so if you remember going back to chapter 10, an interface is an empty class. What it says is, when you use me, you are agreeing to a contract, meaning if I have variables, which we won't have variables, most likely we'll have variables, but we have just method names, which says you will have methods that have these names. You have to write your own code, by the way, but they'll be there. So here's the public interface action listener. Public void action performed action event E. So that's basically pretty much what an action listener event interface looks like. Okay. So when we implement that, we have to have a method called action performed, and we need to put in an action event object, and it's going to be called E. So, so here's one private class, my button listener implements action listener, public void action performed action E, and then we write codes to handle the action event. Again, action event is a class as well. So we have a class called action event, and we're going to have an object called E that's going to utilize that. So write in an event listener for the Kilo Converter class. So if we go over to the Kilo Converter in the next little folder here, so pretty much the same thing's going on. Well, we got Kilo Converter extends to JFrame, so it basically inherits everything that JFrame has. And I create a JPanel, JLabel, JText, and a JButton objects called panel, message label, Kilo text field, calc button. Have my two constants for the window size, and then I have my public Kilo Converter, which is the constructor for the Kilo Converter class. It's a no arg. I set the title, I set the size, I set the default close operation, I build my panel, I add my panel to the window, and then I go ahead and say the windows equal true. Visible equals true, so now the window displays. So when I do my build panel, I got my message label, I have my Kilo text field, I have my calc button, and so up to this point, we've done everything up to this point. Now I have this calc button add action listener, and we're going to instantiate a new calc button listener. Okay, so we've just created an action listener object, and we're just basically passing that to this calc button add action listener. So the method add action listener now just received a listener. Panel equals new JPanel, so now we've instantiated a new panel. Panel.add message label, Kilo text field, and calc button. So now we now have the window and form that has all the stuff that we saw before, but now when they click the button, it says I can do something now. But what's it going to do? Well, we now have this class calc button listener, which implements an action listener. Okay, so when we instantiated this, notice I do not have an object name. Why? Because since it's part of this class is inside of our class, this is now an inner class inside of our outer class, we don't have to have an object name. We can just refer to this class inside of this class section, this inner class. So then we come in here and we say public void action performed. So here's a method, and we're going to receive an action event called E. I've created a constant called conversion, and it's 0.6214. I've got a string input. I've got double miles. My input, I go ahead and say Kilo text field .get text. Ah, that's pretty cool. It says go up to that Kilo text field up above that object and .get text. It says anything that's inside that text box will basically be inside of that get text method, and it will be now put inside of the input variable. Miles is now equal to double dot parse double input. So we're converting string into a double, and we're multiplying it times the conversion. So we're taking the input up here, which is text, we're converting it to double and multiplying it times conversion, and then putting that into miles. And then I say JOption pane, show message dialog box, input, which is what we typed in. The kilometers is, and then miles is what we basically just did the calculation with, miles. Here's my public static void main. So I've got a lot going on inside of this class. It's got everything, it contains everything I need. It's got a public static void main, lets me execute. It's got my listener class built inside as well. So let's see how it works. So now I can type in 60, click calculate, and it comes up and says 60 kilometers is 37.284 miles. So again, when it basically got to this guy right here, it took that constant of 0.6214, multiplied times what I inputted, and then basically put that into miles. So again, when I basically clicked on, so I said the calc button now has a listener. Now when I click on it, it basically does something. Okay, so we also have some constants that are colors. We have color.black, cyan, gray, light gray, orange, red, yellow, so on and so forth. You can see those on table 12.3 over there on page 778. So many of the swing component classes have methods named set background. So we can actually say set background to a certain color. To use these colors, we've got to make sure that we import java.awt, and it's all part of that. So now I can say JButton OK equals new JButton OK. And I can take this object OKButton.set background to the color blue. OKButton.set foreground to yellow, which means the background's blue, the font is yellow. So if we look at the color window, so again, the color window extends JFrame, so I mean it is a JFrame class. We've got our label button. We've got two buttons, it looks like. I'm sorry, three buttons. We have a label and three buttons, and we have a panel. We've got the height and width of that panel. I'm sorry, of the window. And then I've got my color window, which is my constructor. And it sets the title, it sets the size. It says what to do if we click on the X. And then we have a message label equals new label. So we set the label to click a button to select a color. Red button dot equal new button red. So the actual button says red on it. The blue button says blue, yellow button says yellow. So now I have three button objects. I say red button.add action listener instantiate it as a new red button listener. There probably is a red button listener. Yep, there's a red button listener class down below here. There's also a blue button listener class and a yellow button listener class. So they all pretty much do the same thing. They're pretty much all identical except for the color. We'll see in a sec. So I go ahead and so now I've got my listeners. It says, what do you do when you click on that button? When you do a click event, we're going to do something. So we go ahead and create a new panel. We instantiate a new panel. Then I say panel.add, a message label, and then I add the red button, the blue button, the yellow button. I go ahead and add the panel to the window. Then I display the window. So my red button listener, when we click on the red button, we have the action performed method that captures the event, and we say panel.set background to the color.red. Set the foreground color to blue. That's the message label. This is the panel. So those are two separate things. And you can see blue does the same thing, yellow does the same thing. And then I have my public static void main, which says the new color window. So it instantiates the new color window. So we run this. And if I click red, change the background to red, blue, yellow. Okay, so up to this point, we've just used the action event listener. Now we need to basically deal with the action event itself. Okay, so the action listener set perform method has a parameter variable that has the E. Remember, we created that E object from the action event. So what do we do with that E? Well, what we need to do is we've got some methods that we can utilize inside of that that object. We have the get action command, we have the get source. So the get action command returns an action command that is associated with the event. When a JButton component generates an event, the action command is the text that appears in the button. The get action command returns the text as a string. You can use the get action command method to determine which button was clicked with several buttons that share the same action listener class. Okay, so when somebody clicks on a button, we got to know which button was clicked. So if we take a look at event object window, is that what it was? Event object window, okay. Yeah, just event object. Okay, so here we've got event object extends the JFrame. I've got my 3 buttons on a panel. I've got my constants for the size. Here's my constructor, event object. I set the title to event object demonstration. I set the size of my 2 constants. I set the default close operation. Then I bring buttons up. So notice I have button 1, button 2, button 3. I say button 1 dot new button 1 equals a new J button, button 1, button 2 is new J button, button 2, button 3 is button 3. And then I go ahead and say add the action listener, new button listener. So apparently down here I'm sure we'll see a button listener. Sure enough, we have a class button listener down there. And I've got button 2, add action listener, button listener, button 3, add action button listener. Now here's the problem. When I click on one of these buttons, I've only got one button listener. That button listener is going to do something, but what's it going to do? It has to depend on the button what's going to happen. So we need to know what button was pushed. So if we come down here to the button listener, again it implements an interface, and the action perform is, so here's our action event E. I can say string action command dot E get action command. So it's a string. So the action command is going to come back. And it says if the action command dot equals button 1, because remember we set that to button 1 up here, we're going to basically say you click that button. If the action command dot equals button 2, we're going to do that. Button 3, do that. And again, it has a method called public static void main. So I run it. Here is my demo. I click 1, and it says you click the first button. You click the second button, and you click the third button. So we know we can have one button listener and we can have it do different things because we can capture which button was clicked. So we now have what is called a flow layout, and a flow layout says how do you want to put these things on your panel. You can put things in specific areas, and so the flow layout is basically how we do that. So we have this thing called layout managers. So let's take a look at the flow window. In a flow window, again, we've got a flow window that extends the JFrame, so it basically has everything the JFrame class has. We've got 2 constants for our width and height, and here is my constructor for the flow window. Know our constructor, set the title, set the size, set the default operation when we close it. We set the layout equals a new flow layout. So, this is new. So now I've got a layout. And we probably have a class down below here called flow layout. And if I look, nope, I do not. Well, we're just going to basically have our set layout, which is part of the JFrame class, and we're going to just instantiate a flow layout. And I've got J button 1, button 2, button 3. I go ahead and make the label of those as button 1, button 2, button 3. I go ahead and say add button 1, 2, and 3 to the current layout. Okay, so what we saw before was this set the panel. Now we're doing set layout, and the layout is again part of the J-frame. And we go ahead and add the buttons to it, and we go ahead and say set visible equals true. So let's see what happens when, and again, we've got a public static void main, so it's executable. I click on it, and notice what it did. It goes ahead. Oh, I hate when I do that. I got button 1, button 2, button 3. When I click on it, I do nothing because, again, we do not have any action listeners in there. So if we go, let's go back to the book, and it says it shows the window that was displayed in the class. Notice the buttons appear from left to right in the order they were added to the content pane. Because there was only enough room for the first 2 buttons, the third button position was basically forced to the next row. So if we were able to resize this guy, so if I were to resize it, notice what it basically does. And if I come down, they stay. So the flow layout defaults from left to right. That's the default. What if we wanted something else? Well, down here I could say flow layout.left, flow layout.right, and it will basically do just as we said. Okay? Be left align or right align. We can also do center. So we have adjusting the flow layout component gaps. So by default, the flow layout manager inserts gaps of 5 pixels between the components, both horizontally and vertically. You can adjust this gap by passing values for the horizontal and vertical gap argument. So I can say flow layout, so there's my class, and inside there I have int alignment, int horizontal gap, and int vertical gap. You pass the alignment constructors just as above. So here I can say set layout, new flow layout, and as we saw in the previous example, we just had a no-word constructor. Now in our flow layout, we're going to actually put in some parameters. I've got flow layout.left and 10, 7. So the first one is the horizontal gap. The next one is the vertical gap. So here's a left alignment, right alignment, and center alignment. That's how it's going to look. So if I were to go back over here and say and then comma, let's make it 20, 15, and let's see what it looks like. So I basically run it now, and notice well, my screen's not big enough to display them, but notice that it basically has some gapping on the right and gapping in between the buttons, which is the 20 and the 15. Notice the buttons are shifted to the right as well. We also have what's called a border layout manager. We can change the border of this guy. And so we have a, now this is very important, we have a north region and a south region. So think of that as the header and the footer. And then in the center we have the west, center, and east regions. So there I can basically do my J panel. So there's my J panel, and I do my button. I set the layout equals new border layout, and then add a panel. So think of these as separate panels inside of the actual panel, and I can actually add a panel button to the north layout, the border layout north. Well, I guess there's only one panel, but we're telling it where we're going to put that particular item in the north. So let's take a look at the border window.java. And again, here's it's border window extends JFrame. We have 2 constants. Here is our constructor. We set the title, we set the size, we set what we're going to do when we close it. And then we say set layout, new border layout. So the layout we're using is a border layout. As the last one we saw was just a layout. I've got button 1 in the north, button 2 in the south, button 3 in the east, button 4 in the west, and button 5 in the center. And then I go ahead and say add the button 1 to border layout north, add button 2 to the south. So I basically then tell it where I want to go ahead and position them. Okay, so these are going to be the labels, and this basically says where I'm putting them. Now, how big are the buttons going to be? That's the question. Then I set visible equals true, and here's my public static void main. Let's see what happens to the size of these buttons. When I run it, oh, as you can see, each button fills up that section. There's north, south, west, center, and east. So, something to think about. When you're using the border layout, if you do not specify a size, it's going to fill up the whole thing. So we have to be able to adjust that. So we need to be able to adjust the button size. So what we need to do is let's take a look at this border panel window. So here's border panel window, and again, extends JFrame. Here's a constructor. We set the title, we set the default, we set the layout is equal to new border layout. Except this, now I've got J panels. So J panel 1, J panel 2, panel 3, panel 4, panel 5. So now I have 5 panels. Now I'm going to say J button, button 1 is equal to new J button. So again, I create 5 buttons, and here's the labels for each button. Then I say panel 1 dot add button 1, add button 2, add button 3, add button 5. So now I'm adding the buttons to the panels. Then I'm going to add the panels to the border layout. So now pack, we'll cover that in just a sec. So pack, and then I set the visible equals true, and then here's my public static void main. So now, remember when we used panels before, we had a default button size. If we just throw a button into a border, it fills up the whole border. If we throw it into a panel, it's a default size. So now what we've done is the last one we threw buttons into our border. This time we're throwing buttons into a panel, then putting that panel into a border. Run it. Now we can see that all the buttons are now fixed in size, and they're centered inside of each border layout. We have another one called the grid layout. It's just like the border layout, except we can tell it how many rows and columns that we want. So if we look at the grid window, grid window extends JFrame, 2 constructors, I'm sorry, 2 constants, here's a constructor, title, size, default on the close. We set the layout to a new grid layout 2 by 3. Okay, so we're telling it 2 rows, or 2 columns, 3 rows. I create 6 buttons. I go ahead and say add the button. Where's it adding it to? It's going to just add it to the grid automatically. So what happens there? I forgot to talk about pack. We'll do that in just a sec. So what we need to do is, wow, what's going to happen here? Well, it's just going to go ahead and throw each one into the grid automatically. Here's our public static void main. So the first button's going to go into grid 1, which is, and then 2, then 3, then 4, then 5, then 6. We run it, and sure enough, that's exactly what it did. But you'll notice also, since I'm not using a panel, the buttons take on the size of the grid. Let's go back here, look up pack. So I looked up pack, and pack basically says this causes the window to be sized to fit the preferred size and layouts of its subcomponents. If the window and its owner are not yet displayable, both are made displayable before calculating the preferred size. So basically it says, hey, I'm going to make all these little small pieces and parts automatically fit into what it's basically being forced to basically be inside of. Now, as we saw before with the border layout, we can basically